learning involves training artificial neural networks to learn from large, complex data sets and make predictions or decisions. Deep learning algorithms are designed to extract features and patterns from the input data, allowing tasks such as prediction, neural language processing, and image and speech recognition to be performed. Deep learning has drastically transformed how we process, analyze, and make data-driven decisions, making it necessary skills for anyone interested in artificial intelligence, data science, or machine learning. Pytorch expands the capabilities of the machine learning framework. It will further provide high speed in deep neural network implementation. Hey everyone, you're watching Simplilearn, and in today's video, we're going to be learning all about deep learning with Pytorch. If you love watching videos like this, do hit the subscribe button to never miss any updates from Simplilearn. If you want to become an expert in the field of AI and machine learning, consider professional certificate program in AI and machine learning by Simplilearn and masters those necessary skills. Check out the link in the description for more details. First, let us understand how is Pytorch used in deep learning. Next, let's look at the advantages and disadvantages of deep learning using Pytorch. And finally, let's build one-layer hidden feedforward neural network. Deep learning with Pytorch is popular in artificial intelligence and machine learning. It is a user-friendly platform for developing and training deep learning models. Deep neural network can be implemented and trained using Pytorch to perform complex tasks such as speech and image recognition, natural language processing, and other machine learning tasks. So now, let us understand how is Pytorch used in deep learning. So, it is used in building and training neural networks, data processing and manipulations, transfer learning, and visualization. So let us know each in detail. Building and training neural networks is made simple by Pytorch's wide range of pre-built layers, activation function, loss functions, and optimization algorithm. Its dynamic computational graphs makes gradient computation flexible and efficient, making it simple to implement complicated models. Next, we have data processing and manipulation. So, to transform unstructured data into useful information, Pytorch provides various tools for data processing and manipulation. Large datasets can be processed and loaded quickly with the help of these tools, keeping the data more useful for use in deep learning models. It improves the precision and caliber of the model. Then, transfer learning. Pytorch offers a variety of features and tools to aid in transfer learning, and it also makes it simple to put those features into practice. It entails starting a new task with a pre-trained model that can be used for transfer learning in just a few lines of code. Next, visualization. Some built-in visualization tools in Pytorch allow for the visualizations of training results, graphs of accuracy as well as loss, and visualizations of the model's prediction. When integrated with other libraries, Pytorch can be useful for developing visualizations for deep learning applications. So now we know how Pytorch is used in deep learning. So advancing, let's look at the advantages and disadvantages of deep learning using Pytorch. Pytorch is used widely in the research and development of deep learning models, and here are some advantages of deep learning using Pytorch. Due to its straightforward interface, Pytorch is simple to use, which make it simple for developers to use and learn. Its user-friendly framework and clear syntax make it easy to use. Next, Pytorch uses robust Python tools and libraries like NumPy to create models and handle data processing. It allows developers to design unique models, layers, and loss functions, supports neural network architectures, and transform as well. With the help of Python's dynamic computational graph, models can be built and modified easily, making debugging simpler. And in order to handle large datasets and build models across GPU or CPU devices, Pytorch uses distributed computing. Pytorch offers strong visualization tools to visualize deep learning models' performance during training. Therefore, Pytorch offers a strong framework for creating deep learning models and a variety of tools for training models.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Next, we have disadvantages of deep learning using Pytorch. First, the hardware needed for deep learning models such as GPU device can be costly, and debugging the deep learning models can be difficult when the dataset is large and complex. Deep learning models need a lot of data to perform accurately, which may not be possible in some applications. And then, deep learning model interpretations can be challenging, making comprehending how the model makes prediction difficult. Now let's build one layer of hidden feedforward neural network. Feedforward neural network is a neural network architecture with a single hidden layer of neurons between the input and output layers. The input layer receives input data in this architecture, and the output layer produces output. And the hidden layer transforms the input data non-linearly and provides a higher level representations of the input to the output layer. Typically, the number of neurons in the hidden layer is determined by trail or error or through some sort of optimization process. So now let's start. So the first step is to import all necessary libraries to ensure that all the tools are available. So first, let's import Torch. Next, import torch.nn as nn. Then import Torch Vision. Next, import Torch Vision dot transforms as transforms. Next, import matplotlib dot typlot as plt. Next step, device configuration. So use the GPU for the computation if available, otherwise use the CPU. So for that, let's type device is equal to torch dot device. Inside this we'll put CUDA if available. If torch.CUDA dot is available, else we'll go with the CPU. Okay. So next, using parameters, let's train a neural network. So for that, we'll give input size is equal to 784. So image size is 28 by 28, that is one dimensional tensor. So total will be 28 by 28 will be 784. So input size will be 784. Then hidden size will be 100. So we can define different size, and then we can give number of classes is equal to 10. So number of classes are always 10. So we have 0 to 9. So we give 10. And then we have number of epochs will give 2. And then batch size is equal to 100. And learning rate is 0.001. Okay, next import famous MNIST dataset. So for that we'll give train dataset is equal to torch vision dot datasets dot MNIST. Give the root. So it is in folder data. Train is equal to true. Comma. Give transform is equal to transforms to tensor. Comma download is equal to true. So train dataset is over. Next we will give test dataset. Same. Here we'll give some changes. Test dataset is equal to torchvision.dataset.mnist root of data train is equal to false. And then transforms is equal to transforms dot to tensor. And here we will not download it. Okay. So next, let's print the dataset for train and test. For that, give print train dataset. And here we got. And also let's give print test dataset. Okay. So MNIST is a popular dataset for machine learning and computer vision applications. It is a collection of 70,000 normalized and centralized handwritten digits 0 to 9 within a fixed size image. So each image is 28 pixels wide by 28 pixels high for a total of 784 pixels. So here you can see we have in train dataset we have 60,000 and test dataset we have 10,000. And the dataset is commonly used for digit recognition task in which the goal is to correctly classify each digit image into its numerical value. The MNIST dataset is frequently used to compare the performance of various machine learning algorithms, particularly for classification tasks. So now next step, let's create a data loader object called train loader, which is used to load the data in batches. So for that, let's give train loader is equal to torch.utils.data loader and of data set is equal to train data set comma batch size is equal to batch size comma shuffle is equal to true. And same goes with the test loader. So let's give test loader torchutils.data loader, and here data set is equal to test data set and batch size is equal to batch size, and then shuffle is equal to false. Okay. So next, create an iterator object. So give examples is equal to iter train loader. So examples from a train loader object it is. Then samples comma labels is equal to examples dot next. So call the next method and then print samples dot shape comma labels dot shape. So here we'll print the size of the sample. Samples is not defined. Okay, so here we got the output. So in output we got the size of the samples where batch size is 100 and color channel is 1 and image size is 28 by 28. So label tensor of size is 100. Next, import matplotlib dot pyplot as plt. So for I in range of 6. So here we are creating a figure with 8 subplots organized in 2 rows or 8 columns. So 2 rows and 8 columns it is. So each subplot shows an image from samples. So for showing rows and columns, we'll give plot, subplot 1, 6, I plus 1. So here it indicates 1 row and 6 columns and index is I plus 1. Or sometimes it will multiply the numbers and display that many images. So it's like 1 into 6, like 6 images it will display. So if you give 2 into 6, it will display 12 images. Next, plot imshow, using that imshow method, samples of I of 0 and C color mapping it is equal to gray. So when displaying the image in grayscales, the color mapping parameters specifies the color map to use. So let's give flat dot show. Run the code from beginning. So here we got. So if you want to change the color, so suppose if I give so this is also a color channel. So here we got in a different color. Or you can also give Verdes. And here we got in different color. So here we gave 6. So we got 6 images. So suppose you want to give 8. So let's give 8. And here we got 8 images. So these are the images from samples. Next, let's define the class from NN module. So for that, give class neural net NN dot module. Def method init to initialize, self, input size, hidden size, number of classes, then super neural net, self, we're calling init method, then self dot layer 1 is equal to NN dot module, NN dot linear, input size, and we are giving hidden size. Self dot relu, the relu function is equal to NN dot relu and self dot layer 2 is equal to NN dot linear, hidden size, number of classes. So here The neural net class inherits from the NN module class. So here we have given NN module, and which is the base class for all neural network modules in PyTorch. And then we are using the init. So the init method initializes the neural network by creating and initializing its layers. So which we have here L1 and L2 layer. And also we have one ReLU activation function, which is this ReLU. And then the first layer, that is here. So the first linear layer takes an input tensor and produces an output tensor of size, input size. And while the second layer takes the output of the ReLU function, which is of the size hidden size, and produces the tensor of size num classes. So next, def forward self comma x out is equal to self dot linear layer 1 of x then out is equal to self dot ReLU of out is equal to self dot L2 of out, and then return out. So here the method takes a tensor x as an input and applies two layers, that is self layer 1 and the self layer 2. So, and rectifies linear unit, that is activation function to it, and the output of the first layer is passed through the ReLU activation function. So this is passed here, and then the final output is the output of the second layer output, and then we print the output. So after this, create a neural network model using the neural net class. So for that, we'll give model is equal to neural net of input size, comma hidden size, and number of classes. So the input size is a hidden size, and the number of classes and the output size are the number of neurons in the neural network hidden layer. So here input size is the size of the input data vector, and hidden size is the intermediate layer between the input and output layers, and the output class is the number of classes in the classification problem. So next we'll give criterion is equal to NN dot cross entropy loss optimizer is equal to torch dot optim dot Adam model dot parameters, comma learning rate, that is LR is equal to learning rate. So here this piece of code sets up the training process for the neural network model in PyTorch using the Adam optimizer, and we are using the cross entropy loss as the objective function. And next, training the loop. So we will check the number of total steps. So for that, n total steps is equal to length of train loader. So it is a length of the training loader for epoch in range number of epoches and for I comma images comma labels in enumerate train loader. Next give, so it enumerates over the train loader. Next reshape the tensor. For that give images is equal to images dot reshape dimension, first dimension -1, comma 28 by 28 to giving it to device. Labels is equal to labels dot to device. Next, initializing a gradient at 0. So there is no mixing of gradient among the batches. So we'll give optimizer dot 0 grade, then loss. So propagating the error backward, give loss backward. Give the optimizing the parameters. So optimizer dot step. Let's give it in one single block. Okay, let's check that. We'll give if I plus 1%, 100 is equal to 0, then print at Pytorch plus 1 divided by number of epochs. Step I plus 1 divided by n number of total steps, comma loss is equal to loss dot item So here for every 100 step during training, the current epoch, current step and loss value are printed. So next, let's give with torch dot number of grade and then n correct is equal to 0, number of samples is equal to 0, and for images comma labels in test loader images is equal to images dot reshape -1, 28 by 28. So send it to device. Next, labels is equal to labels dot to device. Output is equal to mode images. So here let's give model and then give predictions is equal to torch dot max of outputs comma 1 and n number of samples plus or equal to labels dot shape of 0 n correct plus or equal to predictions is equal to labels dot sum dot item then give ACC is equal to 100 of n number of correct divided by n number of samples. Print accuracy so here the outputs variable contain the predicted output of the neural network for the given dataset, and the torch.max outputs comma 1. This function returns the maximum value and its index. So the prediction variable is set the predicted class index for each sample in the dataset, and the n samples variable keeps the track of the total number of samples in the dataset, and the n correct variable calculates the number of samples for which the predicted class matches the true label, and the accuracy is calculated as the percentage of the correct predictions. So here it says the name loss is not defined. So the error is name loss is not defined. So here let's add a piece of code. So outputs is equal to model of images and loss is equal to criterion of outputs comma labels. So now let's run it. So there is no proper spacing here somewhere. So let's run it. And here we got the epochs, steps, and the loss. So I used Pytorch to implement deep learning neural network using the MNIST dataset for digit classification. And the accuracy of the model that I scored is 97.53. So if you want to, increase the accuracy, you can change or modify the layer architecture or the parameters.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
And with that, we come to the end of this video on deep learning with Pytorch. So if you like this video, share it with your friends. And before I sign off, make sure you subscribe to our channel and hit the bell icon to get all the updates. We'll be back with more such interesting videos. Until then, keep learning and stay tuned to Simply Learn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.